This is Mrs. Heisemel. Today we're going to talk a little bit about gear ratios for my automation and robotics course. So before you can get too far into gear ratios, you have to figure out the idea of force and torque. So force is a push or a pull that goes in a straight line. Pushing something across a table is using singular linear force. But if you take that force and you put it in a turn, that becomes torque. So torque is a push or a pull that's essentially in a circular direction. So we're going to use that idea to talk about some gear ratios. So if you look at this animation, and gear A is the smaller one, gear B is the larger one. If you put the motor on gear A, then you can see that this right here, gear A, is turning all to follow it all the way around for that distance, however far that is to get all the way around. It's going to go about half as far on B. So it's only going to get to there with one turn on A. So it's slowing down the actual motion. So if the motor's on A, you're slowing this down, which means if you're slowing it down, you're increasing your torque. And you figure out your gear ratio by looking at output, which in this case is B, over input, which in this case is A, because A is where the motor would be attached. So that would give you 40 to 20, which is a gear ratio of 2 to 1. Now, that being said, motor, if you put it on B now instead of on A, so now your motor's sitting here on B, turning it to go all the way around one time on B is going to spin A twice. So you see how that's going to speed up gear A and make it go faster. So when you're starting with a large gear and going to a small one, you get it to go faster. Because in this case, our output is A, which is only 20 teeth, and our input is B, which is the 40 teeth right there. And so then you get the gear ratio of 1 to 2. So notice in the first example, when the motor is sitting on A, you're getting more torque and less speed. But when you move the motor over to B, you're getting more speed and less torque for that gear ratio. So one of the other things we like to look at is examples. So in this example, you can see that you have an input gear which has 8 teeth and an output gear which has 40 teeth. So which one of these is the input gear? That's correct. The smaller one here would be your input gear. This guy over here would be your output gear because your smaller gear has only 8 teeth. So that gives you a ratio of 40 to 8. Remember, because output goes first. So it's going to be output is 40, input is 8, so 40 to 8, which reduces down to 5 to 1. Your torque will increase. So my motor is here. So I have a motor on a small gear turning a large gear. My torque is going to increase. The speed will decrease because those two things are opposite of each other. Whenever torque goes up, speed goes down. Each output gear, so in this case, the output gear here will have to go around 5. It's going to take 5 turns of the input gear to get that output to go once. So it only turns 1/5 of the way around on the output for one whole turn on the input over here. So that's how we figure that out, is that's how we say that it's a 5 to 1, because our output is 5 times larger than our input, which means that it's going to go much slower, but it's going to have a lot more torque to go with it.